Section 7.2, our objectives for today are the student will be able to graph simple rational functions, translate simple rational functions, and graph other types of rational functions. So you can see we have rational in that. Remember, rational means can be written as a fraction. So now we're going to have one function in the numerator and one in the denominator. So rational functions have the form of f of x is equal to p of x divided by q of x. So there's where our rational part comes from. We have one function divided by another, where p of x and q of x are polynomials, and q of x is not equal to 0, and that's because, remember, you cannot divide by 0. So you have to have that restriction on there that q of x is not equal to 0. The inverse variation. Now we skipped section 1, which talked about inverses, but again, those that cancel each other out. The inverse variation function, the parent function for that is f of x equals a divided by x. That's, again, the simplest one we could have. So we're going to look now at the textbook. And so on page 366, we're going to look at the core concept of this. And so the parent function for the simplest rational functions. So the graph of the parent function f of x equals 1 over x. So again, that's our parent function for rational functions, the simplest one we can have. The graph is a hyperbola. So it's kind of a parabola turned sideways with a reflection of it, which consists of two symmetrical parts called branches. So these will be called the two branches of the hyperbola. Any function in the form g of x equals a over x, where a is not equal to 0, has the same asymptotes domain and range as the function f of x equals 1 over x. So what this is telling us is, if we take g of x, no matter what number we have on top, it's going to have the same asymptotes as the function f of x, which is our parent function. Your asymptotes are, remember, asymptotes are vertical lines or horizontal lines or just any line that a line approaches but does not cross. And so our vertical asymptote is going to be here at x equals 0, so the vertical line running up and down, and our horizontal asymptote will be at y equals 0. And that will be any time it's in the form of 1 over x or any number over x. That's where your vertical and horizontal asymptotes will be. So now we're going to look at the example here in the textbook. So it says graph g of x equals 4 over x, and compare the graph with the graph of f of x equals 1 over x, our parent function. So the parent function is here in blue. Okay, that's the parent function. It's always the same. So we're going to graph this. So when you're graphing, they don't show this here, but you always want to start by putting in your asymptotes. So we have a horizontal asymptote at x equals 0, and a vertical asymptote, at y equals 0, and a vertical asymptote at x equals 0. So your x and y axes. So we draw in those asymptotes. Then we make a table of values. And with these, I would just always start when x is 0. Okay? But that's where your asymptote is, so we can't have a value there. So I'm just going to put an x there that tells us we don't have a value we're going to graph. And then we can just go above it 2 and below it 2 from the vertical asymptote. And so we plug 1 in here, and 4 divided by 1 is 4. And plug in 2, 4 divided by 2 is 2. And we plug in negative 1, 4 divided by negative 1 is negative 4. And 4 divided by negative 2 is negative 2. And so now they show that they've plotted these points. And so all you do now is you plot those points. So at negative 4, or negative 1, we're at negative 4. So here's our point there. And at negative 2, we're at 2. And that's enough points to get the graph. And then all you're going to do is through those 2 points, like they did here, you're going to approach those asymptotes, but you won't cross them. It'll get closer and closer, but not cross. And then on the other side, at 1, we're at 4. So 1, we're at 4. And at 2, we're at 2. And again, they did 3, which gave us that, but just enough to see what the graph's doing and to draw the graph. All right? On the assignment, when they ask you to compare it, you just need to draw the graph of the function. You don't need to draw the parent function every time because it's always the same. All right? So if we go back to this. So we did example 1. So what I'd like you to do on this one is just simply make the chart. I'll trust that you can graph the points on there. So what I'd like you to do is make a chart for g of x equals negative 6x. So go ahead, pause the video here, and then go ahead and try it. So if you did it correctly, if we make our chart, remember our asymptotes are still going to be, because it's in this form, are going to be at x equals 0 vertically and y equals 0 horizontally. So I'm going to start my chart at 0, and I'm not going to have a value there. I'm going to plug in 1, and I'm going to plug in 2, and I'm going to plug in negative 1 and negative 2. So if you plug it in, negative 6 divided by 1 is negative 6. Negative 6 divided by 2 is negative 3. And if I plug in negative 1, that would be 6. And negative 2 would be a positive 3. And so that would give you the information you would then plot and graph on the assignment. Right now, you just need to make the chart. So now we're going to be graphing translations of simple rational functions. And so remember, we've done transformations a lot. All we're going to be looking at today is the h and the k. So it says to graph rational function of the form y equals a divided by x minus h plus k. Remember, this could be f of x or g of x or whatever it is. And I know it's spaced out a little bit here, but it looks like this: a divided by x minus h plus k. And the same thing happens as it always has happened with the hk. Here it just affects the x, so it's horizontal, sends us left and right, and it's the opposite of what it says. And k moves us up and down from the parent function. So our steps to graph these. First thing we're going to do is we're going to draw in the asymptotes. Now the asymptotes change a little bit when it's in this form. Before they were at 0, 0 when it was in the form of a over x. When it's in this form, our vertical asymptote is going to be at x equals h, and our horizontal asymptote is going to be at y equals k. We're going to plot the points to the left and right, just like we did of the vertical asymptote. And then we're going to draw the branches of the hyperbola through the points and approaching the asymptotes. So let's look at an example of this. So they ask us to graph this and then state the domain and range. So I'm going to go ahead and put my graph right here. So remember, our first step is to draw the asymptotes. And remember, if we look back at this, our asymptotes, vertical is x equals h. And so what you have to remember here is your h, remember, is opposite what it says. So my h is actually negative 2 because it's supposed to be x minus h. So I have at negative 2, I have a vertical asymptote. And my k is negative 1. And so I have a horizontal asymptote at negative 1. So now we're going to make the chart. To make the chart, we're going to start at our vertical asymptote, so at negative 2. So we don't get a value there. And then we're going to go 2 values to the right, 2 values left. So remember, from your vertical asymptote, that tells you your middle value of your chart, and you go 2 above it and 2 below. So now we're going to plug in negative 1. So negative 1 plus 2 is 1. Negative 4 divided by 1 is negative 4, minus 1 is negative 5. Now I'm going to plug in 0. 0 plus 2 is 2. Negative 4 divided by 2 is negative 2, minus 1 is negative 3. And then going the other way, we're going to plug in negative 3. Negative 3 plus 1, negative 3 plus 2 is a negative 1. So that would be negative 4 divided by negative 1, which is 4. Minus 1 is 3. And then I'm going to plug in negative 4. Negative 4 plus 2 is a negative 2. Negative 4 divided by negative 2 is a positive 2 minus 1 is 1. And so now we can plot those points. So at negative 4, we're at 1. Let's do this, yeah. And at negative 3, I'm at 3. And at negative 1, I'm at negative 5. And at 0, I'm at negative 3. Now again, you can just do 2 points. If you want to do more points to get a little more accurate, that's fine. But all we're going to do is we're going to draw a graph approaching these asymptotes to get one branch of the hyperbola and the other branch of the hyperbola. And you're done. So again, remember, determine your asymptotes, make your chart, plot your points, and get your graph. And again, you don't need to do any parent functions on this. So, let's see how you, and the domain and range. Forgot about that. So the domain and range, remember the domain is the x values. The domain and range on these is always going to be the same. It's everything except the asymptotes. That's where I don't get a value of x. So my domain would be, it can't be negative 2. So I'm going to put x cannot equal negative 2. The textbook puts it everything except negative 2. I just put domain cannot equal negative 2, and that means it's everything else. And then the range, remember, is your y values. So in this case, the y can be everything except it can't be negative 1. So y cannot equal negative 1. So that would be the domain and range. So again, pause the video. Try this one, y equals 1 divided by x minus 1 plus 5. So graph that and then state the domain and range, and then come back and check and see how you did. So if you did this right, remember our vertical asymptote would be 8, x equals h. So let's go ahead and draw our graph. So we're going to plug in a vertical asymptote at opposite this, so 1. And our vertical asymptote at k, which is 5. And then we're going to make our chart. And our chart is going to start at 1. So we're going to go 2 and 3. 1 we don't get a value for is 0, negative 1, and we just plug them in. Negative 1 minus 1 is a negative 2, so it would be a negative 1/2 from 5 would be 4.5. Plug in 0, we'd have negative 1, so that would be negative 1 plus 5 is 4. Plug in 2, that would be 2 minus 1 is 1, and that would be 6. And then plug in 3, 3 minus 1 is 2, 1/2 plus 5 is 5.5. So, go back on this and plug those in. So at negative 1, we're at 4.5, approximately there. At 0, we're at 4, and so this side of the branch is going to look like this. And then the other one at 2, we're at 6, and at 3, we're at 5.5. So we know now that this half goes like this. And that would be your hyperbola. So pretty easy to do. Make sure you find the horizontal and vertical asymptotes, and then make your chart, and then plot your points. Now, graphing other functions. So not all functions are in that form. We sometimes have functions that are in the form of y equals ax plus b over cx plus d, where we have a single power linear polynomial on top and the bottom. So these also have graphs that are hyperbolas. And so to graph those, now the vertical asymptote you're going to find by the equation x equals negative d over c, so the opposite of this divided by c. And your horizontal asymptote will always be at y equals a divided by c. So using that, we're going to graph and then state the domain and range. So let's go ahead and start with our vertical and horizontal asymptotes. So remember, negative d over c. So that would be, in this case, negative d would be 3. So our vertical asymptote would be at 3 over 1, which would be 3. And our horizontal asymptote would be at a over c. So a is 2 over 1, so that would be at 2. And so now I can start my graph. We have a vertical asymptote at 3. So our vertical asymptote is at 3, and our horizontal asymptote is at 2. And now we make our chart. So again, we're going to do it the same way. We're going to start at 3, plug in 4 and 5. 3 we don't get a value for, 2 and 1, and we plug them in. So 1, 2 times 1 is 2, plus 1 is 3. And so we get 3 on top, and 1 minus 3 is a negative 2, so negative 3 halves. Plug in 2, that would be 4, plus 1 is 5 in our numerator. And 5 minus 3 is 2. Or 5, sorry, plugging in 2. 2 minus 3 is negative 1, so that would just be a negative 5. Plug in 4, that would be 8 plus 1 is 9 on top. And plug in 4, that would be 4 minus 3 is 1, so that would be 9. And then plug in 5, that would be 11 on top. And then 5 minus 3 would be 2, so 11 halves or 5 and a half. So now we plot those. So at 1, we're at 2, we're at negative 5. And at 1, we're at negative 1 and a half. And so this is going to look something like that. And then the other side, at 4, we're at 9. So I'm just going to approximate there. And then at 5, we are at 5 and a half. And so this one's going to come like that. And that's all you have to do to graph those. Same process, you just have to find the vertical and horizontal asymptotes differently. The next thing, we're going to be able to switch it from this form to this form so that we can do it. To do that, you want to use long division. I know it's not your favorite thing to do, but that's what we have to do on this. So let's go through example number 4. We're going to rewrite in the form of y equals a to the x minus h plus k when it's in this form. So what you do is you do the long division. So we go ahead and divide. Remember, x plus 1. These are really short to do. And then 3x plus 5. So remember, you take what you have to multiply the first term by to get the first term there. So to get from x to 3x, we need to multiply by 3. And so you multiply the whole thing by 3. And you get 3x plus 3. Then remember, we're going to subtract, so we change the signs and add. So the 3x and the negative 3x cancel. And we get 5 plus a negative 3, which would be 2. So now remember, this is my remainder. So this would be 3 plus 2 over x plus 1. Well, look what happens. We want it in this form. We just put the remainder first. 2 over x plus 1 plus 3. And so our h is negative 1, opposite that. So our vertical asymptote, we now know, is that x equals negative 1. And our horizontal asymptote is our k value, which is 3. Okay? On these, I'm not going to have you graph them because you're going to do enough graphing on the assignment. But now, so we've written it in the form. And if they ask you to do domain and range, pretty easy. Domain would be x can be everything except negative 1. So x is not equal to negative 1. And the vertical your range would be y is not equal to 3. It can be everything but that. So, and then they're going to ask you to describe the transformation. So remember, plus 1 would be left 1, and the k would be up 3. You don't have to worry about the a value. All we're going to worry about is the h and the k on this assignment. So remember, horizontal, opposite what it says, so that's -1, so it'd be 1 to the left. And +3 is what it is, and that's vertical, so that's up 3. So I have 2 more problems for you to try. So I'd like you to try to graph this one and then state the domain and range. Although let's just make a table. You don't need to actually graph it, and state the domain and range. And then on this one, you are going to rewrite in the correct form and then describe the transformation. So go ahead and pause the video, try these 2, and then come back and see how you did on it. So the first thing we should do on this one is do our vertical asymptote, which remember that would be -d, so that would be 2 over 4 or 1/2. And our horizontal asymptote would be a over c, so that would be 2 over 4 also. And so that would be 1/2. So we have that. We can now make our chart. I'm just going to start at 1/2. So I'll do 1 and 2 and 0. So we don't have a value for 1/2. So we plug in 1, that would be 2 plus 1 is 3. Plug in 1, that would be 4 minus 2 would be 2. So we get 3 halves. And then we plug in 2, that would be 5. And 8 minus 2 would be 6. And the other way we plug in 0, that would be 1/2 negative. And plug in 1, that would be 3 and 2. So you could plot those if you needed to, but I'm not going to ask you to do an assignment. And then we tell the domain and range. Remember domain. So the domain, remember, it's what x can't be. And so that's our vertical asymptote. X cannot equal 1/2. And our range would be y cannot equal 1/2. So that's what you should have gotten on that. On this last one, supposed to rewrite it in the form of y equals a to the x minus h plus k. So remember, we do the long division. X plus 1 into 2x plus 3. X to get to 2x would be 2. Multiply the whole thing, 2x plus 2. Change the signs and add, so this cancels. And we get 1. And so it's plus 1 over x plus 1. So now we just switch the order. Okay, and then we're supposed to describe the transformation, so it would be left 1, up 2. And you're done. And that's what you're going to be doing on this assignment. It takes a little bit of time on some of these, but on assignments on page 373 to 17, the odds, you're going to graph those on 3 through 17, and then on 25 to 39, you don't have to graph those. Okay? You're going to do this assignment on the paper. It's not going to be on the Big Ideas Math. I want you to do those graphs, and I want to be able to check them that you know how to do that. So, good luck on that.